Hi, Manu. Hey, Dan.
Hey Mark.
Hey.
Hey Dan.
Hey, hey.
So yeah, sorry about the scheduling snafu. It's Rihanna's doing a good job, I'm sure. It's just that the meeting invites aren't coming through. Like I certainly haven't seen the updated one. Um, so I don't
Oh,
know
that's
what's
weird.
going. I
It,
don't know.
it
I,
yeah, it did
I
show
got
up.
it from this. Yeah.
Yeah, it did show up on my calendar
Huh. Okay.
this morning. It did just this morning, like 15 minutes ago.
Yeah, yeah. I just checked a couple of minutes ago and still no from me. But glad you made it. So um I'm just gonna give Summer. Um I'm going to give people a few more minutes to file in, and then we'll decide. There's a couple of things we can do today, and we need to, again, uh, due to this messed up scheduling, I didn't like send out an agenda or anything, so we'll figure it out. So the couple of, so there is, we need the charter. There is a draft charter. We could go through this, clean it up a little bit. The sooner we didn't get that done, the sooner we can get our own mailing list. And I think that would be nice to have. The other thing is we have two gap analysis documents now, one on Whimsy and one on Spiffy. I wrote a draft one on Spiffy. I then messaged Peter Castleman because he is the product that he's the director at Spiral. I was hoping that he would, critique it, and I haven't seen anything yet. But I really do feel that the gap analysis is best done by people closest to the technology. We'll see. So those are the three documents we can take a look at today, and then towards the end of the meeting, we'll decide on the tasks for the following week. So, I think that the easiest and least contentious thing we can do right now is the charter. So let me share my screen. We'll move right
And
into
Mark,
it.
I
Yeah.
know I know I have a task, and I'll get to it when I can, but it's really crazy. So,
Well,
but
you're the one who works for a startup. I am, you know.
thank you for recognizing it. Yeah, it's really, my life is a nightmare, but I mean in a good way. In a good way, I must say.
Yeah,
But
great
very
nightmare of life you got there. Okay, let's see. What screen am I sharing? I'm sharing this screen. Let's do that. There we go. All right, so I wrote this draft, and then how about this? I'm going to place the um, Zoom. I'm trying to.
Hello,
Um,
Mark. So
hey.
did you manage to share it somewhere, this document? It seems I
Yeah,
haven't
yeah,
seen
yeah,
that.
yeah. It's
Okay.
in. So okay, so the folder for where all our uh, documents live.
So didn't we decide last time that we will move to the Git repo rather than these Google Docs?
Yeah, we don't
It's a
have.
bit
We do have that. I don't. We do have a GitHub now. We just haven't placed anything in there. So here's the folder, and yes, I think it should be an MD file, the charter, but no, let's just work with what we got, and then we can transfer. It's this format makes it a little easier to work on the initial version of the doc because of the commenting ability. It's harder to do with pull requests. So, anyway, I just put the link to the document into the chat.
I
So
requested access. We
you did, okay. Let me grant it to you. All right, you should have it. again, if you don't have access, I'm happy to grant it. All right. So yeah. And then I would like to also, so Hank went through, made a bunch of suggestions. I accepted a bunch that were good, but then there's a bunch that I looked at and said, this just doesn't roll off the tongue very well. So I want to, there isn't a lot of commentary here, but let's clean this paragraph up first, and then we'll go through the goals. Or so the the definition of trustworthy identity is something I'd like to also finalize today. So on this, improve the creation of mechanisms. I said influence the creation of mechanisms because, well, I mean, certainly we are seeking to improve, but I don't believe we can create the mechanisms ourselves. I think we can work with, you know, the ecosystem. There's an emerging ecosystem. It'll move forward with us or without us. That's sort of the reality of it. But the hope is by getting ourselves involved, we can influence mechanisms that would actually, work well with the confidential computing. So again, we can phrase it however. I welcome your inputs.
Yeah, without him here, it's hard to know if what he had in mind was that the SIG would actually write code.
Right.
I'm sorry, who had that expectation?
That's Hank. So
Oh.
he's an IT of old hat.
Yeah, I know Hank.
Yeah.
So the thing I continually struggle with is Mark, you approached this and you said zero trust is an important concept in the industry, and we talk about trustworthy workloads and stuff. I feel we need. I mean, I would prefer to call zero trust workload identity as opposed to embracing trustworthy, because everything is trustworthy today, right? We don't verify anything, so by default we trust it. What confidential computing gives us is the ability to actually verify and have the least trust assurance. So so for me, it really is all about assurances. It's about not trusting. It's about verifying everything.
I broadly share what you're saying. And I wrote this document, which again, I can blow up the.
But I would Mark and Manu, I would kind of disagree with that thing, because the reason is, firstly, you are not having the, so what guarantee do I have that it is the least trust? Can you justify me somehow?
Yeah, least trust in the sense that you need to trust the manufacturer of the chip and the endorsement of that specific TE. And
Yeah,
then
but I would just, sorry, I'm interrupting, but I would argue right here. So you are trusting the hardware, right? Other mechanisms don't need to trust the hardware. For example, fully homomorphic encryption. So I think it's not the least trust. So the least trust terminology by itself is quite wrong.
in homomorphic encryption, you don't, I mean, yes, homomorphic encryption is mathematically probably the least trust, but you need to implement it somewhere. And if you don't verify the systems where you manage that homomorphic encryption, you actually don't have any assurance that that system is not leaking information. You only know, you don't have to trust the math, of course, but you still have everything around the math, right? The way that the math is carried out, is implemented, and everything around it to implement the math could actually leak information. So
No, but so then the hardware can also leak information, right? So I think that the comparison that you are trying to do is not a fair comparison, right?
No,
So if you want to call it a least trust, you should somehow justify me that all of the technologies that exist in the space, out of all of those, it is the least trust. And I don't think
there
that's the
is
case, right?
there is a definition of least trust. I was actually quite surprised that this was defined by NIST. And NIST really I forgot, we can probably, if you do a quick search on least trust, you'll see that it basically is the limiting the number of components in a system that you have to trust and limiting the extent to which you have to trust those components or these.
So, folks, I'm going to have to rope this back because we're
Okay.
not going to make progress towards the ultimate goal with this. We can take this particular conversation to the mailing list. I will draw your attention to the document on the screen to which I put the link in the chat. And this is where I literally took NIST wording on what zero trust approaches are. And approach number one, which is ZTA using enhanced identity governance, is the one we'll be addressing here. So we can, my suggestion in the interim at least is we keep the term trustworthy, because trustworthy, we kind of broadly understand what it means. I actually disagree with you, Manu, on that everything's trustworthy. No, there's a bunch of stuff that's trusted. Trustworthy is that you can actually, know why you're granting trust. But this particular document breaks down the identity governance zero trust into the 7 tenets. And on all of those tenets, it basically explains, like one by one, how confidential computing assist can help. And with that, please review it. Let's go back to this, where whatever term we assign to this concept, we still have the same goals, right? So let's talk about first. Let's fix up this paragraph real quick, and then a good chunk of work can be done today if we simply agree, or some modified version of the set of properties that identity needs to, or workload identity needs to have, in order for us to assign that moniker to it. Okay, so let's do this one first. I can leave it until Hank joins, or ask him to critique it, but
Well, I guess maybe some progress we could make without him is I look down at the goals, and the second goal is integration. So maybe if you could say a little bit about what you mean about integration there.
Integration. Let me see.
In the goals section at the bottom, just as far as saying like what it is that what kind of work that this SIG would do.
I see. Okay, so what I mean by integration is that we have Spiffy, we have Whimsy, we have Rats. They're all effectively reference architectures, and they all contribute to the notion of what workload identities, whether through attestation results in case of Rats, or the SVID ecosystem with node attestation in terms of, like in case of Spiffy, or with the Whimsy tokens, right? They all take crack in this nut. And what I'm saying is that we need a way, and this is what I would call the reference architecture, that allows us to translate between these domains that overall help get us to a point where when you use a technology in the workload identity space, you understand how confidential computing integrates with it.
Okay. So with something like Spiffy, we're going to do sort of like a document integration, if you will. If we were to integrate with in Toto or some software package, that would mean actually adding code. Is that an objective?
Well, that we may have to, yeah. So, for instance, for Spiffy, we have an architectural clash, right? Because in Spiffy we have node attestation, and node attestation is something confidential computing wants to actually get away from, except for where is my device located, maybe some other properties of the device, but the workload itself is actually isolated from the device. So we need to so the reference architecture needs to explain how do I do confidential computing assisted workload identity and still get an SVID. Right? And again, we have a set of requirements that are in the separate document that we have under the attestation GitHub. That meeting all of them is going to be challenging, right? So that anyway, I do want, so we can leave this paragraph for later if this is not going to be productive to discuss now. But I do want us to have a discussion on, so if I'm saying I have a trustworthy workload identity, as opposed to just workload identity as it's achieves today. What are the key essential properties? This is why I have the if and only if term here, right? And I started with the 2 requirements. I quickly realized that there'll be a few additional ones. Number 4 specifically is the one that Wenhui suggested that I disagree with, but and we can discuss. And then 5 and 6 were added by Hank. So can we quickly review and have a discussion on, so, if we can, at the end of this meeting, have this, done, and then we agree on the goals, I think we're pretty much done with the charter at that point. So specifically, I think 4 is trying to be an inverse of 3, and I don't think it's a necessary condition. It may be a desirable condition that, so for instance, if I say, here's my workload credential, I look at it, and by some mechanism, I can point back to where the workload was built from, and I have that unambiguous link. It's nice to also have a set of instructions by which I can take that lineage and I can reconstruct the workload from it. But I just don't believe that that is a necessary condition. I think it's a nice to have. Like if I believe the link going back, I don't need to also prove it to myself with a link going forward.
I think I kind of know what you mean by lineage, but maybe.
Okay, so here are some examples of lineage. One would be, I can tell you the version of the source code and all configuration of the build tools that were used to create that workload. And I believe the build system. Like there is some trust to the, the fact that I simply trust based on maybe some out-of-band policy that this gives me the correct lineage on which I can then make further decisions. Things like, is it patched, is it up to date, is it whatever, has the static analysis been done, whatever. Number 4 is on the other part of sorry, before I continue, the other example of lineage is this workload came from a vendor I trust. And we have a contractual obligation with that vendor to do certain things, so I don't need to worry about it again. That's lineage. Right? It's effectively some marker indicating the supply chain by which the thing has arrived. And it's not in every case. Not in every case can I, point to the original source code. That's not going to be always possible.
Yeah, I kind of agree with that, Mark. The thing that bugs me in its absence in those conditions here is we have confidential computing give us very, very strong authentication of the workload and very strong assurance of the integrity of the platform, of the TE itself. But we don't have anything that talks about the same level of assurance for the lineage or for the reference values, for everything else that is used in the decision to verify that indeed it is the right workload. So although we may have very, very strong workload identity, if you don't have equally strong identity and authentication methods for the lineage part of it, then why are we doing all this work in the first place? Right? Because the weak link, the relying party, the other workload that we're trying to connect, right? We're trying to solve the Alice and Bob problem. So Bob, to make a decision to connect with Alice, needs to know that all the pieces, so that the the evidence and endorsement values that come from from Alice, that
Yes.
the business logic that is implemented in the middle to compare
Mhm.
the evidence and endorsement values with reference values, and the reference values themselves, all of it needs to be of equal strength. Otherwise, Bob is like saying, great, you give me great evidence, but I don't know if the reference values are strong. So I
Okay.
think this
Yeah.
is, to me, the reason why I'm here, because I think this is the unique opportunity for Confidential Computing Consortium is
Mhm.
to come up with a template that says, wait a minute, we need to secure all three pieces.
Yeah.
And we should really care about the strength of all three pieces. Otherwise, it's pointless to do all that work at the silicon level, because we're going to weaken it as soon as we
Okay.
get out of the silicon.
So I hear you.
Oh,
I hear you. Let me give you an example that perhaps challenges your thinking and see what you think. Imagine that we achieve what you just said, that I have a complete and unambiguous linkage, right, to exactly everything that went into creation of the workload. I now can establish the trust in the build chain, okay, and whatever else you meant by your statement. Let's say we did that. Let's now also assume that the code that was measured and that became, got mapped into the workload identity has some severe vulnerabilities in it. So I do not know, it doesn't encrypt its incoming traffic, it doesn't encrypt its logs, it has a buffer overrun, it's just buggy code. That's running in the trust execution environment and the lineage is perfect. You still can't trust this code. You don't even know if it's the code that got measured because of the buffer overrun. So I'm afraid, I guess, that if you set your goal to be too maximalist, then you become lost in the weeds. So this is where I would like to pop up a level and basically say, look, what we're going to say is the workload is confidential integrity isolated from its hosting environment. Note that I'm not saying that the workload is bug-free. The only thing that we're insisting is that the workload is
As intended.
as created,
Yeah,
as
exactly.
launched. Okay.
As intended. What the intention being, the intention, from the lineage, that Mark at JP Morgan actually put that workload on that specific machine.
Right.
So that's that's the best we can do, because indeed we can't, make sure that you didn't inject some bugs in there.
Exactly. So this is how I would achieve. Go ahead.
I would like to add my perspective here. I think that's not impossible to do that. That's actually possible. So there are techniques from formal verification that we can use in combination with this whole of, let's say, confidential computing and all of that to guarantee that the code also was not only as intended, but also was bug-free. So I would not say that's really kind of impossible, although that's quite challenging, because if you have millions of lines of code within the TEE, that's and a whole VM and all the things inside, so it's a bit of a challenge. But I wouldn't say that's kind of impossible. At least at some abstract level, you can have some kind of guarantees. And coming back a bit to the point that Manu made, that the three kind of chains in the whole spectrum, we have to take them together. One of them he was saying was basically the workload identity and authentication and strong authentication. I would fully disagree with that, because the protocols that we have currently today, sorry for that, Manu, but I have done a lot of research on this. That's what I am saying, because we also talked to the TLS working group, and I will post a link afterwards. We had in the workload identity a few discussions about the gaps within the confidential computing. And that's why I was hoping that probably we can also get them resolved here, because I think it's really I mean I feel it very hard to digest that we have problems within the confidential computing and we say that, hey, we can solve that problem. So I think the problem starting point would have been better if we could solve the problem of the identity within confidential computing. But anyway, I just wanted to correct that the workload identity itself is not correct. The protocols that we have currently today do not actually provide you a strong authentication. It's even weaker than the standard TLS. So I will put a link in the chat by which we have done the analysis.
So we can add ensuring that a workload identity is trustworthy by means of protocol, but that would go under goals. It doesn't go under the definition, Osama. So
Right,
let's
that's fine.
absolutely
I
do
was,
it.
yeah,
Let's
yeah.
refocus back on the definition. And let me speak to, and by the way, yes, go ahead and propose to, like, you have edit access, go add a goal as you see fit, and then we can, wordsmith it. But Manu, in SVID, there is a field, only X509 SVID has it, but it has a unique identifier for each credential, right? So if we can know that each credential has an identifier, and we maintain this identifier as effectively a key of some index, then we can then look at the workload credential. We can access the store where some information about the credential is stored that's not in the credential itself. And then we can look up information based on that unique credential identifier that would then tell us something about the workload lineage. That would actually satisfy requirement number 3. And how good that lineage is clearly up to how the system is engineered. But, in this working group, we can't solve every problem under the sun. We can simply say, if these key properties are met, you're good. Or to the best of the ability of the system engineering, you're good.
Yeah, but as you said, right, we're talking about a reference architecture, and you basically punted saying there's a whole bunch of things in the reference architecture that is out of scope for this, but all of it inherently weakens all the strength that we have at the silicon level.
So you can incorporate requirements by reference. So for instance, in order for a workload identity to be believable, your workload development and delivery practices need to be sound. This is, by the way, in the GRC SIG, we have a document on how to govern a confidential payload from design through to implementation and deployment. Right? Now, we're not going to list all of that here, but we can basically say, maybe we can add a part to the definition. Your workload identity is trustworthy is among other conditions. The payload, the trustworthy payload is also properly governed per this other document. You're not like if you're going to create a complete and exhaustive contract of every possible condition, will never be done.
No, I understand that. What I'm saying is that the technical mechanism that we have, and Osama, I know you work on the protocol, and I agree with you. And next generation of confidential computing chips will be better and will keep getting better. So I'm thinking about the ideal confidential computing chip. We work very hard to isolate the workload. And I think what we should contemplate is that the workload should protect its own information. So it should have its own keys so that it doesn't leak information outside of its own isolation boundaries that we work so hard to establish. And then once you incorporate that into your thinking, then you say, great, now every workload can have their own keys. How do I manage the lineage of those keys themselves, or the security of those keys themselves? And that gives you a reference architecture that can then be propagated, where you can propagate along a chain of workloads that are all capable of protecting their own information, so that you have composability that is itself cryptographically protected all at the hardware level. So that to me is, I was hoping and I'm thinking that this should be what this work group is about, is what is the reference architecture that is optimal from a confidential computing consortium point of view, that doesn't weaken all the hard work that went into making the silicon verifiable and the workloads verifiable. And so from that reference architecture, then we can say, fine, if you want to relax some of those requirements, if you can't extend the chain of verification all the way to existing workloads or existing systems, that's fine. That's where the boundary of that reference architecture is. And then there you have automatically weaker authentication, weaker verifications, weaker cryptographic security. But within the boundaries of the reference architecture, you've maintained the strength that was built at the silicon level.
Okay.
And to me,
So
that would be the ultimate goal for this exercise, in my
so there is
perspective.
a lot that you can unpack requirement number one into. So when I say the workload is confidential, integrity isolated from its hosting environment, that we can put sort of Federalist papers around it, or so some Talmudic context, if you would. Right? We can say, well, the silicon needs to be designed in a certain way, and the workload needs to be properly governed per this other set of requirements that was right, and etc. We can basically say all of that. It's just when you're doing a bullet point definition of what a trustworthy workload identity is, you're not going to capture all that richness in a bullet point. You can put clarifications, footnotes, etc. around it, which I'm more than happy to do, right? I will also say that until we know what the trustworthy workload identity actually means in terms of this definition, reference architecture itself becomes impossible.
So Mark, I have one quick suggestion for you. So
Yeah.
feel free to ignore it, but is it really necessary for the purposes of, so we are discussing the charter, right? Is
Yeah.
it really necessary for the purposes of the charter to really put in a precise if and only if with exact number of definitions and with a precise definition? I don't think folks will actually agree on this. So are you really, are we, in other words, what I'm asking is it really worth the effort to have, or are we delaying actually the whole charter thing because of this? What do you
Well,
think?
it
Is it
depends on
really
how
absolutely
contentious it's going to
necessary to?
it's how contentious it's going to be. I actually believe it's not. I don't believe it's a very contentious topic. I think it forces us to think about what it is we're hoping to accomplish. And then once we're done with that, then we are in a much better position to actually go and accomplish it.
Yeah, I completely agree, but it could be, I mean, if you put if and only if, that's a very strong statement, right? So, and that's saying that if one of the condition fails, it's not trustworthy, right? So
Yes,
I'm not saying that you need to absolutely have, let's say, or remove all of this, but I'm only saying that do we really need to have it precisely
well,
written down for the purposes of the charter?
I really think we should at the very least attempt it. And by the way, the only top three were authored by me. Okay, the other three were added, and I do not actually believe we should be putting too many things on this list. I think we need to keep, the core definition very, very tight, right? Because then that actually reduces the scope for contention.
But on if you see actually the very first point, it's only saying that it's isolated, but it doesn't say what the workload itself is.
Well,
Like,
so if it's not properly governed, it's not going to be isolated. If it's run on poorly designed silicon, it's not going to be isolated. This is footnote sort of thing, which we should definitely explain, but it does, like, we don't need to make that, clearly spelled out in the bullet point. Like,
I didn't get that. So what is the connection of the confidentiality and integrity isolation to the workload identity being trustworthy?
so the connection is the following. If my workload can be arbitrarily encroached upon by its hosting environment, then any statement it makes about itself is not trustworthy,
Okay, got it. Thanks.
right?
And
So,
what
and
about the
again,
second one?
the second one is binding. So if your workload identity is expressed as a bearer token, then it's not a trustworthy credential. It's not a trustworthy identity because you don't know if it actually came from that workload instance. And the third one, lineage, is the one that actually allows you to find out per your own policy whether you want to actually, it's not actually enough for it to be isolated and tightly bound. You also need to know where the hell does it come from. Why would I trust it?
I'm not sure about the third one, but I think I follow what you are saying, and I agree with you on the first two.
Okay, well, I mean, we may decide, and this is I'm perfectly fine to scope it down. right? There may be a bunch of nice to haves. Maybe tracing lineage is nice to have, but to me, I don't know if something is trustworthy just because, you know, I know that Bob is Bob, but I know nothing about Bob's lineage. That's not trustworthy.
Yeah, it doesn't make sense.
Like that's like okay, yeah, that's Bob. That's for sure Bob. No question about it. Is Bob any good? Maybe I need to have a way of asking questions about Bob.
Well,
Yeah, but I mean, it's more about, sorry, Manu, go ahead.
No, you go ahead.
Okay, thanks. So I was trying to maybe I think at least the word lineage is not understandable probably for at least for me. So probably you might I see what you actually mean. I think I am in spirit agreeing with you, but probably consider rephrasing kind of this word lineage, which might
Well,
or
okay, so this is what we
better
could
to
do.
explain.
This is what we could do. This is what I suggest we do.
I mean, I actually like the word lineage. I've been thinking about this problem a lot, and I couldn't find a better word than that one. So I was quite pleased. It's difficult. It's not the provenance. It's more than that. It's the linkages with all the other things that you need to know about so that you can trust Bob.
So allow me to make the following proposal. And this is going to be another to-do. Add clarifications of deeper meanings behind bullet points 1, 2, 3. For example, and I can just put some things here. What does it mean for a workload to be isolated? Properly governed payload per GRC SIG requirements, properly engineered silicon, right? So we can essentially make all that footnote stuff, right? And then we can basically say lineage. What does it mean and why not provenance? We can have that like clarification document, we can put it in the appendix of the charter, basically saying, look, if you're really looking for deeper meaning of why we're saying what we're saying, that's what we meant.
Makes sense.
Right? Importance of lineage as part of core definition. Right, so things like this can go into appendix. We can wordsmith them. What would be very important for us, however, to say like the tightest possible definition of what makes trustworthy workload identity without anything that can be stripped will allow us to then say, to evaluate any reference architecture that results.
Hank has his hand up.
Yeah, please.
Oh, yeah, am I muted? I don't know. Sorry, I'm
Hi, Hank,
a little
you're
bit,
late comer today.
Yeah, because I didn't get the invite.
Yeah, sorry
So,
about
but
that.
I got the email. That's not an
Yeah,
issue.
yeah.
So, in SBOM world, and that's also some old technology, I think, so it's not super popular. There is this software heritage term. Maybe we should also differentiate with it. Lineage and heritage is very, they appear in the same context often. So maybe we can differentiate that also as a reference, just as context, right? Because I think this, what you're calling lineage here has overlap with what this software heritage identifiers. And that's already, that someone built that, but it's not super popular, I think. So it's just there, I think, an SPDX 2.3, and it basically fades out now. So, but if the concept, as you said, if you can't add or remove anything, and if you have the perfect definition, that sounds like a good idea. Sorry, and I'm pretty sick, I'm sorry.
Any other thoughts?
So on the number one item there, so when you say the workload is confidentiality isolated, I think we're talking about the information, right? The workload.
Sometimes about code, and we should add a clarification to that.
You're talking about the code itself.
Yes. An example of that is a video game, right?
No,
You
no,
do not want
I
to be able to pirate a video game.
I appreciate that, but like, for instance, Bob is supposedly a trustworthy workload.
Yeah.
But somehow the information that Bob is using to carry out some processing, maybe some metadata or some bits that Bob needs to be able to process and carry out his function, have been altered outside of Bob's isolation boundary.
Yeah.
How do you know that you can still trust Bob? So I think
Right.
there's the isolation of the code itself from a confidentiality and integrity point of view. But for Bob to be trustworthy as a workload, Bob also needs to be able to secure its own information. So whatever other things that it cannot hold into its own isolation boundary for the life of that workload, right? For its life.
A
So it's
lot
the
of that is
information
actually in the
confidentiality.
GRC SIG. So we talk about, for instance, one of the core tenets, and it's sort of something I impart on people all the time, like bad configuration will make good code do bad things, right? So when we talk about what code you're running, it's equally important to say what configuration is it running it in. So for instance, what is configured as Bob's root of trust? Right? That needs to be measured as part of Bob's workload identity, evaluated per some kind of policy. And then you will know through this level of interaction that Bob did not get an information from some random source. But that's, again, that would be captured through a level of interaction by saying your payload is properly governed.
So here, this is a composability problem, right? Where you're basically saying you have multiple things that you need to compose to be able to trust Bob. And what you're saying here is that it's okay to have composability that doesn't have the same strength as what the TE gives you. That policy is enough to just say, hey, there's a root of trust, so there's something, or the key comes from a non-random, source, and there's no way for Alice to verify that that's the case for Bob. Alice just has to trust the policy. What I'm saying is that precisely the opportunity here, because Bob could actually generate his own keys and could actually protect its own information that it needs to be able to process things on, for Alice, that the workload itself should protect its information. Not have that composability, or if we compose things indeed, that the composability process is itself as strong as the isolation, the confidentiality and integrity isolations that we get from each TEs that are involved in that composability. Again, I go back to the opportunity here for the CCC to establish a reference architecture that fully leverages its capabilities and doesn't punt on, okay, so as soon as it's outside of the isolation boundary, we can rely on governance and policies, because that is not verifiable. And so we basically, drift away from the concept of verifying everything. Anyway, that's my perspective.
So one perspective that I have
basically thousands of applications written in Python and JavaScript and God knows what, that's legacy, right? That it's going to be difficult to achieve sort of, perfection in there. But what we do need to set here is some kind of a set of practical, adoptable concepts that we can say, okay, do that, and you'll be able to, no, by the way, nothing is perfectly trustworthy. Nothing is, intelligence agencies leak, and as you know, like governments fail us all the time, right? So we're not gonna over constrain, or we're not gonna be successful at trying to over constrain anything.
But this is not what I'm saying, right? What I'm saying is the reference architecture should be CCC or confidential computing centric.
Yeah.
And then anything that's not, that cannot fit because it's legacy technology and we can't yet migrate it into this kind of reference architecture, that's fine. We're basically saying it's just not part of it. And we know that there's a clear boundary when you interconnect with a piece of JavaScript or Python code that is outside of a TE, that now you actually have a clear delineation between what's in the confidential computing reference architecture and workloads that do comply or do abide by this reference architecture that are as trustworthy as can be. And then when you get out and you interact with legacy stuff, well, you relax the, inherently, it's less trustworthy. And that's the world we live in, and that's understandable. But it gives you now a North Star to say, great, that workload that is not trustworthy, it's not because of confidential computing that it's not trustworthy. It's because it's not running in confidential computing that it's not trustworthy.
Yeah, it's kind of the right. I think I agree with you. The poster child is you did everything right, and now you're using bearer tokens to communicate your identity.
Exactly,
Well,
exactly.
yeah.
And that's one of the issues that I have with Whimsy and Spice at the ATF. I'll be at the meeting, in a couple of weeks, but is that we start from a weak place. We start, and the ATF, by definition, start with existing standards, and then is trying to bridge and bring in kind of the strongest, kid on the block right now, the confidential computing stuff. And so you end up having, one very strong link in the sea of weak links. And I think we need to do the reverse. From the CCC point of view, we should look at what is the strongest posture possible, and then explicitly relax it when we need to interface with something that
I think
cannot
we're
be
in agreement on both of these, right? But ultimately, when I say reference architecture, if that reference architecture does not integrate, doesn't have impedance match with what's out there, including bearer tokens, right? With all the unfortunate side effects of that, then we are lost. And this is where this is the kind of complexity that bullet point 1 hides, is that there is a lot of stuff you need to understand to really unpack what it means. We can still explain it. We can explain it in the appendix. We still need to arrive at something very succinct that allows us to proceed.
I have tried to capture this point as point number 7, which is kind of also covering my point. And you talked about the bearer tokens. So I think that's one thing is, or one bit of that is that it is the identity is securely provisioned to the TEE. And the second point is that whenever it wants to communicate to some other entities, such as some other workloads, it is
Yes.
securely conveyed. That
That would be
contains
the second
protocol
part. The second part would be captured by number 2.
The second part would be part of number 2.
Secure conveyance is part of number 2. But secure provisioning is something we need to think about, whether it's one of the core properties.
Well, actually,
Maybe it's also part of number 2.
I actually don't think that the identity is actually provisioned to a TE, but it's more
Yeah,
like,
I mean, ideally not, right?
Right.
Ideally, what you
Because
want is you
now
want
you
the
have-
TE to generate and certify its own keys.
that's right. So
But you need to be able to arrive at a set of properties that capture your entire space. So, for instance, if we insist that identity is certified, generated by and certified by the T itself, then we need to understand what happens for Lambda that runs for a second and runs 1,000,000 times an hour. Does it hit the verifier 1,000,000 times an hour? Because every workload needs to provision its own or generate its own credential? Probably not going to scale. Right? Or maybe there are mechanisms we can advocate, such as you launch it, you do the job once, and then you seal the credential to the platform, and then on the same server, you can just
Correct.
reuse it. That again needs to be in the footnotes somewhere.
Okay.
But
Right?
I
So
don't
I'm just
follow-
very careful about the wording.
Yeah, it's fine to I kind of argue. I mean, I just wrote it down. It's not yet very refined and so on.
Mhm.
But I'm still thinking about if the key is so there was the problem in the protocols that I previously highlighted is the same. Like you generate an ephemerally generated key that has no connection with the certification authority. You essentially became your own certification authority, right? So you lost the notion of that PKI, and now anyone can claim to be anyone. So that identity is to be bound together with that identity. So I think the two have to go together. That's kind of my point
Well,
in
so there's
this.
something about the issuance of the credential that needs to be like the credential must be issued by a party you trust, which it's like almost axiomatic. Like I mean, we can include it as like requirement number 0, right? I mean, how do you trust the credential itself? Well, you need to trust the issuer of the credential.
Mark,
And
yeah,
it's true.
I agree with both of you, but what I like about Usama's perspective on the, Usama very much thinks in terms of protocols, which is interesting because it requires 2 parties. And
Yeah.
I think number 2 does not convey that image, right? Does not create that mental image that what we are eventually trying to achieve is Alice and Bob being able to communicate with one another. So I like the idea of talking about 2 entities or 2 workloads, as opposed to just having this abstract concept that is buried into what you say that
What if I were to
is
expand number
bound to.
2, where it says the credential representing a workload is bound to the workload instance, and the recipient of this credential can establish trust in the issuer of the credential?
Yeah, so my general comment, and unfortunately I have to drop off. I have another call in 10 minutes. But I think in this governance document or this charter, we should very much try to emphasize the fact that the end goal, given that we have a goal section, is the establishment of secure information sharing between 2 workloads, and that will, I think, better encapsulate everything else that we're trying to define, because then now you have identity in the context of a relationship with another workload, and now
So
you're talking
under
about
goals,
Yeah.
under goals, we could add one. How would you phrase it? Let's basically let a goal 0.
But
The goal.
I agree with Manu. I think it's not a goal, but rather related to that workload identity, right? So if you want to define it as an if and only if, I would consider that really as a part of the definition rather than having it as a goal. So
Yeah, more like a
I like the
conflict
way
with the
Manu
whole stuff,
phrased
huh?
it. So
But Osama, I think it's both, right? I think it could be a goal, or it should be. We should express it as a goal that this is we won't solve the Alice and Bob problem. We need to enable workloads
right.
communicate securely with one another, and then
But
in
what
the
I'm arguing, what I'm arguing is that it should also be reflected as part of the definition. It's
Yes.
obviously a goal. We want to have it. As I said, the gap analysis that we have done is clearly showing that it is missing. That
Yes.
is definitely a goal. There is no question about that.
Okay.
What
So
I'm saying
Osama,
is
let
that
me
it should.
let me ask you this question. So I agree, like we should definitely say, what our goals are, and perhaps being able for 2 parties to be able to, have a certain agreement and establish trust in what code runs on each end is a worthwhile goal. So we can phrase that. I have no problem with that. However, look at every definition out there. No definition will ever tell you what goal it's seeking to achieve, like tensor, derivative, matrix. Yeah, you have definitions, but the goal is never part of the definition.
Yeah, but that is okay. The goal is never part of the division, but it should be adjacent to it. Also, measuring with the lower bar is maybe not the goal here, right? Sorry, the pun. You could do better, right?
So that's why I would like, and when you say adjacent, once we define what trustworthy identity is, which is this section, goals immediately follow. So they are adjacent in that sense.
Yeah. Okay. Okay. Makes sense.
Right. So I want to arrive, like I can't say the goal of trustworthy identity without defining what trustworthy identity is. That's why I put it first. Let's have some definition, and then like you read any
Some
math
characteristics.
textbook, somebody comes to you and says, here's the definition of something. Now let us walk through how this definition helps us achieve certain goals.
Let me reread the 3 ones that you think are the essential ones. You didn't at the end, because the trust in the issuer kind of feels like obvious, but you have to make sure that you can always easily check trustworthiness. That's a low-cost operation, and I think that was captured by your end, and you can put trust in the issuer, I think, with a 2, or what was it?
Can be
Somewhere there, I
to the
guess.
workload image as well as its issuer. can be traced back to the workload lineage and the workload issuer.
Sure.
That's it.
Because
That
because
gets us everything.
trustworthiness means nothing if you can't cheaply check it.
Yeah, and sorry, and the
Yeah.
credential issuer.
Yeah.
All right, so if we get those three, I believe everything else sort of gets dragged along for the ride. And then we'll add footnotes. Okay, 5 minutes left. That's when we talk about the for the next week. Please give the review to gap analyses that have been written. Complete the tasks assigned to you in the sort of mainline document that we have describing our progress. Let's get the charter finished, and that's enough for 1 week. Sounds good?
Finished for review by the wider audience at the tech, or finished for
No,
actual charter
let's
procedure?
aim to finalize the charter next time we meet, which means perhaps working offline on this document, just like Hank, you've been doing. You and I.
Yeah, I try to do that because
Okay, I'll send out the meeting minutes after I hang up, and then I'll see you guys all next Tuesday.
So one quick question,
Sounds
Mark.
good.
Yeah.
So
Uh-huh.
I guess you created the charter for the GRC, so you have experience with all the bureaucratic stuff. So what's the most important section that they need in order to get this going?
I think the most important thing is all of us who are working on this document agree that this is the document, so we can move on to other things.
So they don't care about the technical details. They just
I don't
want the
believe
working
so.
group to agree on what exactly the problem is that
Yeah,
they
we
want
can
to
bring
solve.
this charter to the TAC and say this is what we'll be doing. But
Mhm.
before we do that, we need to speak with one voice and agree on, at least the broad outline of what it is that will get done.
Okay, if that's the case, I would still be thinking more about not putting if and only if kind of things that we can make it going faster to the tech, but it's up to you to
No, I
make the decision.
think I want the definition tight as possible. I think that's going to be very, very important for. And by the way, my background is as well STEM as yours, Osama. Like it's just you are deep in the trenches of formality, and I'm probably one level above that. So yes, I do believe that we need to get pretty tight on what we mean by trustworthy workload identity, because so much will depend on our common shared understanding of what that entails.
Right, thank you.
All right. See everyone in 2 weeks, and then
I
any
think
questions, any
Catherine wants to
discussion?
say something.
Sorry.
She has
Oh
her
yeah, please
hand
go
up.
ahead. Yeah.
Oh yeah, I was just responding to the comments. I put the comments in the chat, and then about the definition of a credential, the distinction between identity and the credential. I feel like the discussion, not the discussion, some of the points about like this point 7 about the identity needs to be securely conveyed to other entities, other workloads. That is already covered in 2. I'm not entirely certain that that's. I don't quite understand why it's covered in 2, unless we're saying workload identity and credential are essentially the same thing.
No, they're not the same thing. They're absolutely
Okay.
not. Identity is very stable over time, and credential can be reissued every minute. But all the credentials issued to the same workload will communicate the same workload identity. So I'm very careful. I'm very careful not to confuse the two.
Yeah, we have to capture that because it sounded unintuitive to me. So we have to really capture that.
Yeah, that would help. Yeah, that would
so
be
for instance,
very
I can
helpful.
say any credential representing a workload identity. That might make it clearer.
Yeah. Identity is the ephemeral thing, and the credential is the document.
Credential is the ephemeral thing. That's like exactly opposite. Credential can be very ephemeral, can live for a while, a short time.
So
Identity is something that relying party is looking at, and that's very stable.
I think let me put it in some other words. So are you both thinking about the ephemeral key that the TE generates as the credential or the identity? Which one of those do you think of that it uses in the TLS connection?
A credential is the X509 certificate would be a credential.
Ah, that's an
Identity.
identity
X509.
document, a signed public key in the minimal form. Okay, got it. That's a credential.
So
It
you
would
mean
be
the
good
self-signed
to
certificate?
clarify that, I think. Yeah.
Okay.
Yeah, I agree
By
with
the way,
Catherine.
Catherine,
So
any
I
comment
think
you
it,
put in the chat is going to be lost once the meeting wraps up. So
Oh.
put comments in the working documents. And by the way, I'm
Okay.
excited. I'm so glad someone from Google is joining us. We need representation from the hyperscalers here for sure. So thank you.
Happy to. Yeah.
All right.
Thank you.
Well, all right. Let's continue working offline. I'll see you guys in a week.
thank you, bye.
Bye.
All right.
In a week.
Take care,
Okay.
everyone.
Wonderful.
Bye-bye.